Hi, everybody. Before we get started, I'd like to say that the last time I was here at MLconf giving a talk, it was a virtual conference. I was sitting in my guest room. It's nice, even though the clothes are a little more uncomfortable, to be in front of a live audience. I'm expecting and looking forward to lots of good questions. So let's kick this off. So today, John Maiden, going to be talking about augmented recommendations. Try this again. Big green button. Perfect. Okay, so we're going to be talking about recommender systems for augmented reality effects. I am a software engineer at Meta. I work in a production-facing team that builds end-to-end solutions that delivers augmented reality effects across multiple surfaces. Perfect. So today, we're going to go into what is augmented reality. I'm going to give a couple of examples of what augmented reality effect looks like. I'm going to be talking about how we go ahead and build the pipeline. So how do a recommender system would look in general, and how does it specifically apply to augmented reality effects? And then on top of that, we're going to talk about this as a content source. So when you're recommending something, you have to think about the content that you're actually recommending. How do augmented reality differ from media recommendations or other types of recommendations you normally would see? Okay. What is augmented reality? Augmented reality is an interactive experience of a real-world environment where the objects reside in the real world are enhanced by computer-generated perceptual information, sometimes across multiple sensory modalities, including visual, auditory, haptic, somatosensory, and olfactory. What this means is augmented reality compared to something like virtual reality, you have a physical environment. So the sensors, the devices are using your existing physical environment, and it's inserting virtual objects or virtual experiences within the physical environment. So virtual reality, purely virtual. Augmented reality is a mix of the two. So when you consider what you're working with, it is both physical and virtual objects, environments, experiences that all get mixed in together. If you've worked with augmented reality before, if you've seen an effect, you've probably seen it on your phone, very common on a mobile experience. There's been a lot of development in the past few years in the wearable space, so you've seen a lot of different companies come out with great wearables. And it's mostly an image-based experience, right? You're going to see it through a video, you open up a camera, you're going to see it from your camera. It'll be visual, it'll be auditory, potentially haptic when you get to the wearable space. Unfortunately, not yet olfactory, in case anyone was wondering. So here are some examples of what an augmented reality experience looks like. You've got a picture of me, because I realized at the last minute I needed a picture to fill up my deck. I've got one of my coworkers who is showing that she can do it. And this is all of us as a team testing out group effects. In this case, it was us going through on a Thursday afternoon playing around with this. The meeting itself got increasingly sillier, but we had a good time. Great. So in terms of the use cases, what are people using augmented reality effects for? Well, first, AR games, very popular. I remember in 2016 when Pokemon Go came out, I was working at a different company at the time, and there's a lot of discussions about this. You know, it was an exciting idea of a new experience for mobile. You could create a virtual environment, you could create virtual objects that people could interact with. What does this mean for your usage for your customers? How do they interact with your app? How do you think about your business? I mean, it's grown beyond that, but AR games is definitely a big driver. AR commerce, so AR ads, virtual try-ons, and I'll show some nice pictures of that in a minute. There are also many other industries that also talk about and have good use cases for what they plan to do with AR. I personally find the education opportunities interesting. I've seen a lot of proposals about overlaying virtual objects on top of a physical object if you're trying to train people to do something or to learn how a physical technical device works. So as you're debugging something or trying to put something together, showing from a virtual perspective what it should look like. So I find that personally exciting. Okay, AR commerce, so virtual try-ons. So you probably, if you've worked with AR, this is probably another way besides games that you've interacted. So you might say, okay, I'm gonna choose a couch, I'm gonna buy a lamp. Can I try it in this corner? Do I do it in that corner? Can I put it on this chair? Or can I move it over here? I'm gonna buy clothes, what does it look like on me? So a way to improve the overall shopping experience, to give you a little, reduce the buyer's remorse, make it a more exciting experience overall. Okay. Back to recommendation systems, that's what I do day to day. So what does a recommendations pipeline look like for us? Well, this is kind of a generic design. It applies to most recommendation systems pipelines. You're going to have the universe of stuff you want to recommend. Could be media, could be, in our case, AR effects. We've got millions of those that we want to recommend. When it comes to recommendation time, we're going to have a sourcing pipeline that'll take millions of those effects and reduce it down to order of thousands. And then finally, it'll get to the final ranking stage, which could be an algorithm, could be a model, but it's going to produce results that get fed back to the client around a couple of hundred. So why do we do this? So first of all, if you have millions of things to recommend, you might have an amazing model, but if you're trying to do this with a low latency and runtime, you're not going to be able to pass millions of objects through a model and return it very quick. So you need a sourcing strategy. Now, part of it is the physical reality of I can only rank 1,000 things at a time, but also you can test out business strategies. What happens if I'm going to recommend, do I pass in the most popular effects that are the trending effects? If they're new effects that don't have a ton of exposures, how do I make sure that those get boosted such that we make sure that those get enough exposure overall? So sourcing is both a physical reality, but it's also testing out different business strategies on top of the existing model that you're going to build. On the modeling side, when it comes to AR effects, there are roughly two workflows that we use for prediction. So one of them is recommending the AR effect itself directly. So you are about to take a photo, you upload your camera tray, you see little AR effects at the bottom. So we are recommending an AR effect by itself to then publish into the picture or the video you're about to take. So that's recommending the AR effect directly. The other workflow for us is AR content that's already embedded into something. So you're watching a video, you're seeing an image. AR content is more of an additional feature on top of something. So as you're building existing media recommender systems, you might say, does this have AR content as an additional set of features? So it's whether you're recommending AR content as a primary driver, so the effect itself and all of the metrics and concerns around that, or are you trying to use it to boost something else that we already have? Okay. On the infrastructure side, I mean, yet again, recommendation systems have typical infrastructure. We're not really going outside of that. But when it comes to AR effects, you've got the typical AR effects that you've probably seen. On top of that, a lot of the AR effects that we have are also location locked. So these are AR effects that are only triggered if you are in a park. These are AR effects that are only triggered if you're in front of your favorite restaurant. So in addition to having technology that supports end-to-end pipelines for normal delivery, we also have to consider place data. We have to partner with teams that give us updated retail information, knowledge that we need to know about the community around you so that we can help creators create these types of world-locked effects. On top of that, AR effects are not tied to any one platform. Which means that any system that we create has to be able to support multiple surfaces. We are working with multiple products, which means that we are supporting current hardware, current products. We also need to think about existing and future hardware development. So everything we build has got to be designed towards where AR is going to go, because as a content source, it's going to move off a camera and it's going to move into future hardware devices, and we've got to think about what that means for the future. And the most critical part is on the AR effects side. AR effects are a content source. That means that the modeling architecture, how we're designing the models, are not necessarily different. We can use normal models and the way we can develop, but we have to think about what makes an AR effect different from recommending images or other content. So, understanding content. So what does this mean to think of something as a content? Well, content means what is it like? What is it? What are its features? Why do people like it? How do they use it? You've got AR effects. You can think of them kind of like video, right? They are four-dimensional. They are three-dimensional. They have a time dimension. They are interactive. This is where things get a little bit different, right? Because first, for an AR effect to work, I've got to place it into video. I can't just show an AR effect by itself. It doesn't have as much meaning. It doesn't. Definitely, the users are not going to find delight just looking at an AR effect. They want to see it used somewhere. So it's got to be applied to something to have meaning, but it's also got to be triggered. AR effects could be me blinking 3 times to get the effect to trigger. If you put it into a video where someone just stares ahead the entire time, you're losing functionality, you're losing the meaning that the AR effect is trying to expose. So it is similar to video in one way, but also because of the interactivity, it is a little bit different. So you have to think about that when you're building recommendations, developing features, trying to think of this as a content source. AR effects tend to come in two themes. You've got world effects, which is physical environment. You've got a virtual object that lives within the physical environment. And you've got people effects. So people effects are effects that are usually tied to body parts that are triggered by motion. So those are two different ways that the effects tend at a high level fall. But in addition, we need to understand what was trying to be delivered by the effect. So is this a game effect? Is this a sports effect? Is this going to be an instructional effect? At a high level, you want to understand what are people producing? What do the creators want to do? What do the users find interesting? And so this needs to be categorized and understood, and it requires labels and discussions and thinking about this with product. One more time. Perfect. Okay, so why focus on this? From a pure modeling perspective, it produces more features. As you know, more features, better data, always beats more complicated models over time. But in general, it helps us from a company perspective to say, how do we categorize these? If this is a sports effect, is this going to be indoors, outdoors? If it's funny, what type of funny? What do people think about when it comes to quality for different effects? What are the levels and impressions that people have over time? So this also understands and helps us categorize consumer behavior, both on the creator side and also on the user side. We got it? Good. Okay. So on the content understanding, we tend to divide this into two parts. We look at this from a video understanding perspective and a code understanding perspective. Video goes back to the thinking about AR effects similar to being like video or images. On the code understanding, it's looking at the internal structure of the code and seeing, can we find patterns in there that tell us about the inner functionality, because interactive, so we want to know all the different ways that an AR effect could be triggered. So why combine this? Why do we just not treat them as video, or why don't we just look at them as code? Why do we need to combine? Well, when it comes to an AR effect, you could have something that is visually complex but technically simple, or you could have something that is visually simple but technically complex. Example I could give is two effects. One of them is Batman running around the room, the other one is Robin running around the room. They look visually different. They are two different effects. But from a code perspective, they would be the same components, the same templates. All I did is just choose a different texture at the last minute to make the motion. But from a code perspective, they're the same. But from a video perspective, they're different. Another example would be two effects. One of them is they both have Batman dancing. In the first one, Batman is doing very simple moves in the effect. The second one, Batman is dancing, spinning, jumping, turning, all of this stuff. In the first effect, the person used the existing templates, the existing components, and built from existing functionality an effect. The second one, they built their own custom code. They went ahead and made a ton of JavaScript improvements. You know, this is something where people went way beyond what we currently offer to make the effect much better. But visually, they're both Batman dancing. But from a code perspective, they are totally radically different. So to be able to understand an effect, we want to capture the understanding from both paths. Oh, good. Okay. Okay, so video understanding. So understanding AR effects as a video source, similar to video content. Okay, so AR is a visual medium. One way that we can turn this into effects or features we can put into our model is thinking about them like video embedding. So anything that we do, we have typically videos of people actually publishing the effect. So user would take an effect, they publish it. That's video that we have of people using the effect. A lot of creators also upload a demo video, so we have that information as well. So we have videos that show what the effect should look like, but the critical part is anything that we see has to include all of the trigger behavior. So we have to make sure it involves the blinking, the motion, the table if it requires that there's a table in the effect. So that's important for us to capture it as a video source. And if we want to, using out-of-the-box computer vision models makes sense to a certain extent because a lot of these are trained on real-world objects. They're trained to identify dogs and cats and cars and trees, which will be present in AR, but it'll ignore all the virtual objects. So you could have multiple effects that are all applied to the same background. The existing computer vision models will all categorize them the same. I saw a door, I saw a cat. I totally ignored a person with half of their face blue and the other half red, because it's not just something that they're trained to pick up. So from a video understanding perspective, what do you do? Three times, nope, oops. How do I go back? Back? Perfect. Okay, So video understanding. So one way we can do this is to say, well, the existing computer vision models have a taxonomy built around common real-world experiences. What can we do to build a new taxonomy that helps us with virtual environments? So that's one effort, is to say, we have a physical environment. There's certain things that are relevant to physical environment for AR, but what also can we create as a taxonomy for virtual worlds and virtual objects? And then that leads us to training new models, creating lots of training data, labeling it, getting it all ready. So all the data-intensive part of building a recommender system is first building models that are actually going to represent and tag and identify what we consider to be valuable for AR. Another way that's a little bit easier on the training data is using something like self-supervised learning. In that case, you can say, I have all of the effects. I know if an effect is the same or not. The same effect applied to two different videos should be the same. Different effects applied to the same video should not be. If I train enough of these and I've got millions of effects to work with, then I can hopefully build out embeddings that are representative of the AR effect itself. So something that is uniquely representative of the AR effect, irregardless of whatever I embed it into. And that's like a goal. It's a little bit noisy, but that's the hope, is that you can create representations that capture information that's always going to be representative of the effect no matter what. On the code understanding side, so a lot of existing efforts on code understanding tend to treat them as an NLP problem. For us, we have components that have already been pre-built, so that's existing language if we want to treat this as a bag of words. But also because people can create their own code, they can create their own components, code their own JavaScript stuff. Then on top of that, that kind of makes it a little bit messier because code's going to be different, but it's going to be the same functionality. It doesn't necessarily capture the information that we really want. So you could say, well, why don't you then go ahead and simulate, run it into a profiler, put an AR effect into a runtime engine and then see what happens. We talked to some people and they said that's kind of like trying to simulating an app and figuring out what an app does. AR effects have so many different paths they can be executed on, so it's possible, but you really need to make sure that all of the different events and all of the different behaviors do get triggered. So how do we do this in such a way that at least it captures a consistent way of representing the information in the code? Okay? Well, one way we can do this is, luckily for us, a lot of our AR effects have an internal structure. They're built around patches. So patches are collections of components that are linked together. So inputs will go to a component, will connote a component, will go to an output. And so we don't have to know exactly what's happening, but we can say, well, these are graphs. These are small-scale graphs. And if effect is made of enough of these, if we can identify common small-scale graphs within the universe of effects, we can help categorize those as an initial attempt. It's going to ignore some of the custom behavior. As new functionality gets rolled out, we're not always going to get there, but at least for most of the effects that we see, especially if you're using default templates, that's going to capture the underlying effects. So not looking at it as a component-wise effect, but looking at it from how the functionality is linked together within the network. So if you find this interesting, we have a studio you can download. You can try to build your own AR effects. If you would like to know more about what's going on in Reality Lab, so we've got the main website. We also have a link to the AR/VR research that's going on. Thank you for your time. Any questions?
Thank you. That's a lot of interesting aspects. I wanted to ask about embedding that we use for VR. So what is the definitional criteria for a good embedding that you're building? And also, when you talk about self-supervised learning, could you elaborate a little bit on that?
Okay, a very self-serving definition of an embedding is something that gives your model a boost. Yeah, no, I mean, like, for something where we have AR effects, like I would say when it comes to AR effects, the self-supervised learning approach, which I'll explain in a second, is to create a representation that's unique to the AR effect. I think that's the goal, is that either you're creating a model where the embedding then leads into a categorization layer, which then says of the 1,000 different options, this is what's contained in this image. And that's how most computer vision models work. On the unique representation, the idea is that if I have an AR effect, I don't have to think about where it gets embedded into. It's like if I put the AR effect indoors or outdoors, on the moon or in a car, it's always going to give me the same representation. And that's a little bit harder. We have data, but that's a little bit harder to build. And then self-supervised learning is that you're not, I mean, the basic definition is you're not labeling the data, right? You are using information that's internally contained within the data to then build your model. So in our case, we're training the data because we know exactly that an effect should be itself. Right? We're not going to manually label. We're not going to create a whole bunch of definitions for the data. We're just going to say, I'm going to throw this effect against a whole bunch of videos. I should always get the same embedding out, the same vector representation out. Versus if it's the same video but two different effects, they should always not be the same. And then that last layer should be your embeddings. Any other questions?
Hi. First of all, thank you for the presentation. This might be slightly off topic, but could you elaborate where these AR effects are running? Are these running on the actual devices? Or these web services that are being called in the moment? And where do you see that going? Will all this, will AR run always on hardware in the future, or are we going to be using web services for this kind of applications?
That's a good question. I would say, I mean, there's mobile and then there's future hardware. I mean, mobile, it's running. I would say, I mean, I'm on the software side, so I can't really talk about where it's going to go in the future, but at least on the hardware, like wearable seems to be the big direction. So yeah, I assume that it's going to, within the hardware, within devices, it's probably going to be there, but it depends on the load, it depends on what design, it depends on what people are looking AR for. A lot of it's short, it's a selfie type, or it's something where you're having, putting a lamp on a table, and those aren't necessarily runtime expensive. But if you're going to do something which is much more intensive, I don't know, maybe, don't know.
Awesome, thanks.
I think we have time for maybe one more question.
Thank you, that was very interesting. I had a question. I also tried, for instance, these types of services. So on Google, I placed a shark on my floor. That was very interesting. But what I found out that it seems to be a little bit clumsy every time I try to use this technology, because then the plane is not detected always, and then the sizes can take, sometimes tend to be a little bit different than they should be in real world. Is it getting better? Do you think that it will be very much usable in some time, or are there many hurdles?
I mean, when it comes to AR, I think partially it's the the hardware limitation. So, you're designing something that's going to work across many different hardware specs. Is that what you're asking?
A few years it was a little bit worse. Now it's getting a little bit better.
Yeah.
So do you see it also, with the technology in the following years, this is going to get more usable than before?
I think so. I mean, the general goal is to make it more accessible. So to move beyond the mobile experience, to allow it to exist on other hardware surfaces. So I think that's a big intent, is to make it as interactive, as useful, to offer variety. I mean, so for us on the content side, it's to making sure that we're helping people expand the functionality so that more can be done with it long term. Okay.
Excellent, thank you.